Hello, dear all. It's me, Nasreen, and I'm so excited to be here for the second session of the Drought course. I hope you can learn something new from this series of video, and I hope you're happy and healthy whenever you are, with full of energy. Okay, let's get started with the main topics in this course, in this session. And we will learn some things, very new topics such as drought types, drought indices, and so on. We can see the highlights now. First, we want to elaborate the main topics with name of what are drought types. Then we will focus on what are the characteristics of drought. And then after we see what are drought indices. And at the end, we will tell you which sources of data would be good and proper enough for us to monitor drought events. Okay, first, it is good to see this graph for drought types. There is a good and maybe former graph about different types of drought, which is published by National Drought Mitigation Center in University of Nebraska Lincoln. Okay, you know, uh, if we want to say that, or maybe a review, it is a good time to see a definition from Will Hyde that he stated about drought. He said that it's neither possible nor beneficial to find a universal definition of drought. Still, some sub-definitions can be categorized according to the disciplinary perspective as different types of drought that you can see here. The first one is meteorological drought, and the second one is agricultural drought, as you can see here, and the last one is hydrological drought. We have another one here. I will show you again in the next I'm in that slide, but please first consider the first one, meteorological drought. In when we can say that when meteorological drought would be happen, we can see some symptoms such as, for example, the first one, precipitation deficiency in amount, intensity, and timing. The second things would be high temperature, high winds, low relative humidity, greater sunshine, less cloud cover. You can see here in this, I'm in that square here, the background of these elements. You can see that all of them would be embedded for a pure meteorological drought. So there are different elements that we can see them when a meteorological drought would be happen. So another, that item would be reduced infiltration, runoff, deep percolation, and also groundwater recharge. We have also another symptoms with increased evaporation and transpiration, both of them. So you can see here the direction of time in this arrow, and according to the past time I'm in the phase with the second type of drought that we call it agriculture drought. In this case, we have some symptoms such as soil water deficiency. In this format of the road, after we see soil water deficiency, we can see that plant water stress and especially reduce biomass and yield. We can see, that huge deducted in amount of deduced in amount of reduced biomass and yield. And by the pass of the time, when the time is going and going, we can see that the last or maybe the third one, hydrological drought, you can see that this, that rectangle here would be continuously when agricultural drought has happened, and also by the time we can see that hydrological drought would be emerged. And what are the main symptoms, such as reduced stream flow? I mean that in lakes, ponds, or maybe reservoirs, we can see and reduce wetlands. Also, another things that we can see in ecological systems, such as wildlife habitat, we can see some changes in these elements. The last option here, the last level here would be another kind of format of the route or type of the route that we call it social economic drought or socio-economic drought, that we can see some impacts in economic, social, and environmental aspects. So if we want to see another, that graph with a summarized format or type, first of all here, we can see less or no rainfall for meteorological drought. Then after in agriculture drought, we can see soil moisture deficit. And after that, in third level, surface and subsurface water deficit as hydrological drought. And at the end, with different impacts that we can see in different systems, it would be impact on supply and demand that we call it socio-economic type of droughts. All types of drought have been distinctive characteristics that vary across different location and also climate types, population, and economic vulnerabilities. All droughts originate from a deficiency of precipitation here as meteorological drought, and after that other types of drought and their impacts cascade from meteorological drought to other types of drought, as you can see here. So, you know, uh, it is a good time that we start for, that the most important concepts related to the measurement of drought, or maybe measurable characteristics of drought. It's really important to know these components. There are basic parameters which are essential to characterize a drought, or namely, the duration here, the first one. Second one would be severity, and the last one would be intensity. The duration of a drought is the expression of how long the deficit of water continues. That it equals the number of months between its start and end. That when a drought event would be started, the duration would be equals the number of months, or maybe number of times it would be the seasonal scales, monthly scales, yearly scales, that it is a start and at the end, up to the end. It would be duration of a drought event. So, but when we say that severity here, what can we call it? From no unified definition of droughts have been divided into different levels, as I told you before. The next one would be severity, which is it has different, the levels, such as we call it moderate drought, severe drought. So the severity refers to the degree of the deficit. The drought severity classification define the ranges for each indicator that I will show to you for each dryness level. So I will discuss it more for you in maybe the next session. But so the better define for severity, if we want to see what can we define it, we can see that it refers to the degree of the deficit. So, we have another items with name of intensity. In this regard, it would be better to see this equation. The ratio of the severity to the duration is called intensity. That when we divided severity by duration, we can see the intensity amount, and it's really another significant drought characteristics. We have other also important things besides three components that I told you. It is really good also for monitoring drought. We call it frequency or a written period, which is defined as the number of drought events in a given time period in any scale, or indicated by the average time between the occurrence of subsequent drought events with a certain magnitude or less. So, frequency of a drought defines the number of drought events that occurred within a given period, that you can see here, the exact equation I'm in that. So, indeed, these properties of the routes are very critical in understanding water management in any kinds of area. However, most prolonged duration and high severity are critical in every system. I mean that such as agriculture systems, water reservoir systems, and different other things. Now, it's good for better understanding this concept, these properties of the route that I showed to you. uh, it is the turn to learn Round's theory, one of the main important theory for learning better and for scrutinizing, I mean, that this concept. Let's see a graph like this. You can see here, the x-axis is related to time, and the y-axis represent to us the number of every indices, drought indices. For example, I will show you what are the indices, but consider that it is X indices that we want to know that what's happened for the amounts of X indices here. You know, drought conditions can negatively affect agriculture, water supplies, energy productions, human health, and many other aspects of society. The impacts vary depending on the type, location, intensity, and duration of the drought that I showed you in the main properties of the drought. All droughts even emerge from the definition of drought indices based on every calculation. I mean, the different calculation it is available for us to calculate droughts. I will show you. So consider that we have X index here, such as a drought index. And according to this drought index, we want to learn some different definitions here. Let's get a start with DD, like here, you can see here, DD. It is drought duration. What is drought duration? It's really easy for you according to see the graphs. Before we will start it, in this line here, which is located in 0 amount, we don't have any conditions of the routes, and we say that in this line it is normal situation. Above this one here, we have some wet situation. All of this area above x0 here, that we have wet situation, and below it here, that below this graph here, uh, below x0, we have drought situation. So DD here showed us, it shows us drought duration. For example, here for the first, that graph here, we can see that it is started from this one up to here. It would be DD. It is drought duration, the time that it takes for that drought event on that area. Okay, so we have another thing such as DS, drought severity, that it previously about drought severity such as DS. It's exactly, if you want to say what it is, you can say that it defines the definite value of the sum of the index during a drought event. That if you make a summation of this one, for the amount of drought, you can achieve the severity of that index or severity of, the drought on that region. In other words, it is the sum of the integral area below zero of each drought event. Here, if you want to see that the severity here, we can see a summation integral here for this area. So uh, we learned DD and DS. Now it is the LD time for knowing about inter-arrival time. Uh, can you find it? Yeah, here, LD. LD, it is inter-arrival time. You can see here when the drought start from this point up to, that this point, this area, this period of time, it shows us inter-arrival time from starts of drought up to start another drought. We have here, that a wet period without any drought, but for this case, we can see that for LD, when a drought start and again another drought will be appear on that region, at this time would be exactly LD. We have another icon in this theory of Ron's theory, the TI, initiation time. So you see that TI here, when a drought would be start from here, we can say that it is initiation time, and also here we can see that it is TI also. So for D and non-drought duration, it's not hard for you. When we have wet situation, as here in this graph, and also in other parts here, when we have x0 equal to 0 in normal situation, we can say that these are a TI. At the DN, it is non-drought duration we have in this time. So for DP drought peak, it's really easy for you to find it. Yes, DP. When we plot a graph for checking and analyzing drought events, when a peak here would be happen for a drought situation, we call it a DP drought peak in the graph of related drought index. Another thing is it would be that x0 that we call it before that for this time, and trunction level, that there isn't any situation such as drought like or the other things. The last one is TE, which is refers to termination time. It means that drought is terminated and we don't have any drought situation. Okay, I hope you can know what's happened in theory of wrongs, and I hope you can learn all the things. If you have any question, please put your comments below this video and ask them to better understanding. I can send you some papers or other graphs to better perceiving this. Okay, I hope you don't be tired because we want to start monitoring drought and what it is. To reduce the damage from the different types of drought, it is crucial to characterize droughts. Drought characterization enables, the operations such as drought early warning and drought risk analysis, which allow improved preparation and contingency planning. So if you want to know this, monitoring drought is a vital and the important part of drought risk mitigation on a global scale. But in my opinion, if you get all the things that I previously told you, it is either on global scale or on the regional scale. It would be because it depends on the area we want to monitor drought events on that area. Anyhow, for drought monitoring, various drought indices have been developed to describe the intensity of a drought. So that if we want to monitoring a drought event in a region, we need to some elements, some that efficient, useful tools that help us to show drought situations. So exactly, it is exactly the time for learning about drought indices. And what can we say, we tell for drought indices? What are they? So, drought indices, for characterization, drought characterization is normally done by the help of drought indices. So, drought indices are tools which combine different data sets and a single number which aids decision making in water resource planning, as it is really crucial for us to do that. And drought indices are quantitative, that measures that characterize drought levels by assimilating data from one or several variables that we call it indicators, such as precipitation and evapotranspiration into a signal numerical value. A single numerical value, I mean that with a single variable, we can understand what happened by embedded several or maybe one, two, or more than this for monitoring drought. Most of the current indices are not precise enough in detecting the onset and an accumulation stress of drought. So uh, we want to know that how many that elements would be necessary for us to calculating different drought indices. Because of the complexity of drought, no single index has been able to adequately capture the intensity and severity of drought and its potential impacts on such a diverse group of users. So drought indices are one of the most important elements for of an effective drought monitoring and early warning system. We need them to quantify and compute the drought even, any drought even, So for there are lots of different papers to put some criteria for a proper more that the best one, the properties of a drought index. But I like Friedman paper that he put some definitions and some criteria for drought, and it's really important for us to know them for maybe if you want to uh, maybe make or produce a drought for a regional scale for your local case study, you should consider several criteria. The first one for basic criteria, as you can see here, the blue one, time scale. The time scale should be appropriate to the problem at hand. It's really important. It is that drought index should be considered this criteria. The second one would be the index should be a quantitative measure of large scale, like continuing drought conditions in green one. So it's really important to have it for such a criteria for drought index. The third one is the index should be applicable to the problem being studied. So it should be applicable if we want to call it as a drought, or maybe it is proper or not, it should be applicable. And the last things, a long, accurate past record of the index should be available or computable, that we can call it a drought index, past record. But one of the former scientists with name of Will Hyde in drought research, he added another criteria beside this the four item that I told you, that I showed you here. He believed that the index should be able to be computed on a near real-time basis. And what it means, for example, indices that are useful for long-term paleoclimate studies. Consider that if we want to use it for paleoclimate studies, wouldn't be applicable for the operational monitoring of drought because of the nature of paleoclimate indices and the difficulty involved in collecting paleoclimate data on a real-time operational basis. So we can't use them, for example, for data such as I mean that tree ring proxies or maybe some evidence such as sediment on ocean, lake sediments, or other proxies. But you know that nowadays for mega drought monitoring, for paleoclimate proxies, we use this, but be careful about them. This is another branch of research in drought monitoring. Anyhow, I think it's really important to know that for the fifth basic criteria for knowing drought criteria, such as drought index criteria, I mean that. Anyhow, I mean that the second step here for drought indices, as you know, a quite high number of drought indicators are used in drought analysis. They are precipitation for meteorological drought, as you can see here. We use precipitation data, and we have lots of different drought indices that they use precipitation for calculating meteorological drought. Beside precipitation, we have another kinds of variable, meteorological variable, that I will show you in next maybe session. But anyhow, we have some indices that they only use precipitation for calculating meteorological drought. So also beside that, soil moisture and crop yield for agriculture drought would be useful for calculating and manipulating, I mean, that agriculture drought indices. And beside that, stream flow, reservoir level, lake water level, and groundwater level for hydrological drought would be essential for us to calculating them. Using the indicators, drought indices, as mean that can quantify these indices. The quite high number of drought indices is available in different literature for the assessment of the drought. Different studies have used different indices to evaluate droughts. Some of them believes we can use, I mean that some different things such as commonly used, I mean that data-driven drought indices such as SPI, KPDI, RDI, ETDI, and blah, 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 PN, CMI, PHDI, SRI, RAI. You will, in the next session maybe, or in upcoming videos, we will uh, get some information about all of them. Anyhow, besides data-driven drought indices, we have satellite-based drought indices. Satellite drought-based indices include the vegetation condition index that we call it VCI, normalized difference vegetation index, NDVI, and also other things, NDDI, WSVI, NDWI. There are different useful indices that we can drive them by satellite information, I mean, that we can calculate them. Anyhow, you know, for the last tip or maybe last important statement in this video, we want to know about sources of data, which our data are proper enough for us for calculating drought indices. The first one would be in situ data, such as synoptic station data, climatology station, hydrometric station, agriculture station. We can use all this station for extracting some of data, such as precipitation, I mean that crop yield for agriculture stations, and I mean that evapotranspiration like that. Besides this thing, it's really good and I love them because we can capture them very easy from different websites, available websites such as Agmera, Crew, TRMM, and ERA, and different new aggregate data set. We can use also that data. We can extract precipitation, temperature, evapotranspiration for different drought indices to monitoring drought and quantify drought in every place that you want. It would be really wonderful for us, such as a researcher, for calculating different drought in a region, global region, a global immediate area or local area like that. And the third one would be satellite data and products, as I told you before, and I counted several drought indices, if you remember in previous slide. But we can use different sensors such as MODIS, MERA, AVHRR, and different satellite products that we can extract them in different format of data to capture some elements such as different variables, and then after calculating different drought indices. And the last or maybe final step, it would be GCM data, global circulation model, such as CMIP5, CMIP6, different global circulation model data that you can also download them from different FTTP proxy and use them very easily for calculating drought. But these are exactly the initial steps for knowing some knowledge about drought indices. I will show you more different things in next video. So for next video, we will find out main drought classification, what are there, and also we want to focus on meteorological drought indices. We want to know that how can we calculate them? For example, in SPI, how can calculate SPI? How can extract the reliable equations from different research papers? I will summarize them and I will show to them how can we calculate them. And finally, I will show you several concepts related to drought monitoring. Okay, at the end, please, I hope this video helps you to better understand how can we calculate drought indices and all the fundamental statements that I showed you. And anyhow, I ask you, please subscribe to our channel with this address that you can see, and also like and don't forget to share it. Put your comments. It's really important for me to know that for comments and your questions. Thank you for all the people that they put in the previous slide, in the previous video, they put some comments for me. It would be really wonderful for me to better understand what you need that I put them in my videos. Please hit the thumbs up button and don't forget to subscribe. I hope you can find new things in this video and it would be helpful, I hope. Thank you so much and I hope you have a good time. Bye bye.